Good afternoon, all of you. My voice is audible? Yes. If my voice is audible, okay, you can scan this QR code for your attendance. If all of you scan this QR code for the attendance, meanwhile, we will wait for another 1 or 2 minutes for others to join. Is I audible to all of you?
Yes, sir.
Okay, so we will wait for a minute, 1 more minute for others to join. So today we will start with a new topic, that is our module 3. Okay, image enhancement. So what are different techniques that we are having for image enhancement, and why we need, particularly why we need the image enhancement. Okay. Okay, I think most of you have joined, so let's start the class. I hope it is visible to all of you. The screen is visible. Yes.
Yes, sir.
Okay, so as I said, already said, today we are starting the new module. This is your module 3. Okay, and the name of the module is image enhancement. Right. So as we know, so whatever image we capture, okay, so basically we provide, so if you remember the different steps in image processing, okay, so the very first process is what you have to do. First of all, you have to capture the images, either we can say either by the any camera or any devices, whatever devices we can use to capture. So once you have to capture the devices, we have to perform certain pre-processing. Okay, so it may be a case, okay, it may be a case, whatever the image we have captured, that may not be clear. Clear in the sense, it may have some noise on it, or it may be in low in brightness or low in contrast, or the image may be a blur. So what we have to do now, that we have to perform certain image pre-processing technique, or basically we say on that capture image which is not clear. Okay, so we have to improve that image. Okay, we have to improve that image while applying certain image enhancement technique. Okay, so basically we will use different image enhancement algorithms. Okay, we will use different image enhancement algorithm to improve the quality of image. Okay, image enhancement is totally depend upon how we can improve the quality of an image. Fine, so that is the need of image enhancement. So why we need image enhancement? The first point you have to remember, during the pre-processing technique, whatever image that we have captured, okay, or whatever the image that is provided as the input, they need to perform certain pre-processing. Pre-processing in the sense, the image may consist of noises, okay, or the image is in low in brightness or low in contrast. So we have to improve certain things on the images. So that particular improvement is basically known as image enhancement. So if you look at the definition, so what the definition says, the definition is very simple here. The image enhancement techniques are designed to improve the quality of the image. Now, what we already discussed, what I said, this is a technique. Okay, image enhancement is nothing but a technique or method that is basically used to what? It is used to design to improve the quality of an image. Which type of image? Which is basically captured or is basically provided as an input to the image processing system, or we can say as it is pre-received by the human being. Okay, whatever the images that is received by the human being or whether it is captured, that needs to be improved, improve the sensing quality. And this improvement can be your either removal of noises or improvement in your brightness or improvement in your contrast or improvement or we can say removing the blurriness in the images. These are the some qualities that should be improved. Fine. A second point you have to remember during the image enhancement technique. Now, this image enhancement can be performed in spatial domain as well as in frequency domain. Fine. So, whatever basically what we have to do now, whenever I will talk image enhancement, so we will going to perform certain operation on the pixels. Okay. Now, this performance can be performed or image enhancement technique can be used. Either I can use for the spatial domain, that means the particular coordinate of pixels, or as well as in frequency domain. Okay, so with on both the representation, whether the image is represented in spatial domain or it is represented frequency domain. Now this image enhancement technique can be performed in any of these two domain, we can say. Okay, you have to remember this is very important point regarding the image enhancement. Okay, so either you can perform in spatial domain or you can perform in frequency domain. In both the domain, we can perform the image enhancement technique. Now, what is image enhancement? Is nothing but a certain image enhancement algorithm. Okay, basically we will implement certain image enhancement algorithm in one of the ideal for a better quality image for the purpose of some particular applications, which can be done by either surprising the noise or increasing image content. So what this point say basically image enhancement is nothing but we will apply certain enhancement algorithm to achieve the better quality image. Okay, the purpose is achieving the better quality image. How it is achieved? Either we can remove the noises from the images or increasing the image contrast, or we can say basically whatever the need is required. So based on that need, we will perform certain enhancement algorithms. Now these algorithms are basically used to improve your image quality. Fine. Now the objective of this module is okay. So what are the main objectives? So first of all, we have to understand why why we need an image enhancement. Okay, in our image processing module. Second thing you have to remember after we can say after completing this topic, we will be able to understand uh, the image enhancement can be performed in spatial domain as well as frequency domain. So when we are performing in spatial domain, what are the different properties we are using? And when we are performing in frequency domain, then what are the different properties or different methods that we are using? Now, second thing we will learn after completing this one is what are the basic difference between point operations and the mask operation in case of spatial domain. Fine. So this is again very important. Basically, in the spatial domain, when we will discuss, so we will discuss with respect to these two types of properties. One is with respect to the point operation, and second one is with respect to the mask operation. Third thing we will be going to learn in this topic is different types of gray level transformations. Okay. Now, one thing you have to remember here. So, whatever transformation or image enhancement that will be going to perform, that will be we will going to perform only in your gray level or gray scale images only. We will not going to use the color images. Okay, we will use only gray level images, that is the black and white images for different type of gray level transformations. Okay, whether it is a point operations or it will be a mask operation. Then we will learn something about how to represent the image in the form of histogram and how histogram equalization property are very helpful for image enhancement technique. Fine, so this we will learn. Again, this is very important. How we can represent basically whatever the image is given. So first of all, we represent the image in histogram format. So once we represent the histogram format, we analyze something. Then for better representation, then we will equalize this histogram. Okay, so to give the better enhancement or better analyzing purpose. Okay, so that we can uh, analyze the data or analyze the image more further clear. And finally, we will learn some of the frequency domain filtering. Basically, we will learn here low level filtering and high level filtering. Okay, so there are two types of filtering that in your course we are having here. So basically, the filtering are used for removing the noises from the images. Okay, so in frequency domain image enhancement, so we will learn how we can apply a low level filtering to remove the noise and how we can apply a high level filtering for removing the noise. Fine, so these are the topics that we will going to cover in our module 3. I hope it is clear to all of you. Yes, it is clear to all of you. Okay, fine. So first of all, so you have to understand what is image enhancement. So we already discussed what are topics that we have to go into cover. So let's move to the next slide. So as I already said in the previous slide, so image enhancement is nothing but, or we can say basically we use that image enhancement algorithm, which is emphasized for sharpness and smoothness of image features for displaying and analysis. So why we need it? Basically, why we need an image enhancement? Basically, to get a more data from a given image. Okay, so basically, what we will do, whether we will sharp the image or we will remove the noises so that it may be clearly displayed. So that when we will go for the some earlier stages like segmentation and feature extractions. Okay, there there we can extract more and more information regarding the image. So that is the main reason for the image enhancement. And these enhancement methods are application specific. So why it is application specific? Now, what type of, we can say, for example, if I need a set of pixels which are belonging to the object, then obviously I will go for the image enhancement technique where the object pixels are represented by the, we can say, the white color. So then in this case, basically we will go for the thresholding. Fine, the thresholding is one of the methods that will be discussed. Okay, so that is the reason this is application specific. That means what actually we need, we will apply that algorithm only, or that type of transformation, or that type of image enhancement. Or sometimes whether if you want to improve the brightness, if some of the objects or the images is not clearly visible. So on that case, so what is application specific here? Or the application specific is the brightness of the images should be improved. Then on that case, we will go for the image enhancement technique, which is used for, or we can say, we will use the algorithm for image enhancement for improving the brightness. That is the reason we said here, enhancement methods are application specific. So based on the application, so whatever application we need, so we will apply the certain algorithm and often develop an empirical result. That means so that we can whatever we get, so that that can be applied for statistical analysis purpose. Now, basically, as we are already said, I already said, now this image enhancement technique can be classified into two categories. Okay, so either you can perform the image enhancement in the spatial domain, or we can perform the image enhancement in your frequency domain. Right. So we can, it is not limited. That means whatever image enhancement you have to perform on special coordinate only. That means f of xy नहीं करना है बोल के ऐसे नहीं होगा. Okay. Now you can perform image enhancement in f of xy, or if you transfer this f of xy into capital F of uv. Okay. Now this is your what? Frequency domain differentiation. So either you can perform your enhancement algorithms, or you can apply your whatever enhancement algorithm in your special domain. Okay, so this is your special domain. Right. Or you can apply these algorithms in your what? This is my frequency domain. So we have already done how to convert a special domain to frequency domain. So we have done Fourier transformation and discrete Fourier transformation to convert any special domain to the frequency domain. Now this is your frequency domain. Okay. Now what we have done now, this image enhancement techniques, whatever techniques we are having, so we have classified into two broad categories. First one is your special domain method. So where we perform the image enhancement algorithm in special domain. And this special domain method basically operates directly on the pixels. Okay, you have to remember this. So whenever I'm performing the image enhancement technique in the special domain, so what actually we are doing? So we are directly performing certain operation on the pixels. Fine. But second type is your frequency domain transformation, or we can say transformation domain method. Right. So this here transmission domain represents your any representation. Okay. Now basically we consider frequency domain. Okay. Frequency domain method or transformation domain method, and the transformation domain method operates on Fourier transformation of image and then transform it back to the spatial domain. So what actually is done? So whatever uh, image enhancement algorithm that we will perform, so we will perform basically on frequency domain or transformation domain. So once that it is performed, then again will be transformed to its by using the inverse transformation. So we will get back the original image in the spatial domain. Fine. So things to remember here. So point to be concluded in this slide is that now your image enhancement technique can be used in both two different types of domain. One is your spatial domain, okay, and second is your transformation domain. Basically, if we talk about transformation domain, that is your Fourier transformation, that is your frequency domain. So whatever enhancement we perform in frequency domain, then again we have to convert it into the spatial domain. Right? And second point you have to remember here. Now this image enhancement technique or image enhancement algorithm are application specific. So what the user is need to analyze, so that type of transformation they have to perform. Okay. So first we will learn about what are the different techniques that we are having in spatial domain. Then we will go for the what your transformation domain or frequency domain. Okay. So let's move on. So I hope it is clear to all of you. Yes, is it clear to all of you? Okay, so the next topic that we have to discuss is your image enhancement in a spatial domain. So as I already said, the image enhancement can be performed in spatial domain and frequency domain. So we will first discuss what are the different type of image enhancement technique that are available in your spatial domain. Okay, spatial domain. Now, if we are talking about spatial domain, the spatial domain techniques deals with the manipulation of pixel value. The first very important point you have to remember. So if I'm saying image enhancement, now suppose this is my image. Okay. Now if I say this is my image, now as we know that basically in digital computer, image are represented by the pixels. Okay, now you can say this is my actual image representation. Now each of these box is represented by the function called f of xy. Yes or no? Now this is basically have two things. One is your intensity. Now this f of xy function represent two things. One is your intensity, second one is coordinate. Okay, the special coordinate is xy, and there is an intensity at this particular pixel. Okay. Now, whenever we say an image enhancement is performed on spatial domain, then we mean that we are performing any setup operation. Now, if I say this is my point P1, okay, if I am saying I am performing certain operation on this P1, okay, suppose I am improving the brightness or intensity of this point P1. Okay, now if I'm improving the brightness of this P1, then what I'm doing, I'm performing certain image enhancement technique. Where I'm performing basically in the pixel P1. So that is enough to say whatever image transformation technique, okay, or whatever image transformation algorithm that we will use, that in a spatial domain, we will going to implement on the pixel values. Okay, तो whatever जो भी हम लोग यहाँ पर इमेज एनहांसमेंट करेंगे, whether आपको नॉइस को रिमूव करना है या फिर आपको कॉन्ट्रास्ट को इम्प्रूव करना है या फिर जूम करना है पिक्चर को, एनीथिंग वॉट एवर यू वांट टू डू एज पर योर एप्लीकेशन, तो हम लोग कहाँ पर बेसिकली करेंगे, तो जो इमेज का बेसिकली पिक्सल के ऊपर करेंगे, ठीक है, पर्टिकुलर पिक्सल के ऊपर ही परफॉर्म करेंगे. इसलिए आप लोगों ने यहाँ बोला है स्पेशल डोमेन में जो भी इमेज एनहांसमेंट टेक्निक आप परफॉर्म करोगे, वो क्या करेगा आपका, बेसिकली आपका वो मैनिपुलेशन करेंगे हम लोग. मैनिपुलेशन मीन्स सम चेंजेस विल बी परफॉर्म and that will perform on your pixel value. I hope it is clear to all of you this point, because with respect to this point, we will going to study rest of the things. Okay, because if you see the different types of classification here, which we will discuss, is based on this pixel value. Right. So remember this first point. So whatever performance we will do, we will perform on manipulation, perform on pixel value. The second point. Now, this spatial domain enhancement, okay, image enhancement in spatial domain is broadly classified into three types of operations. Okay, the first is called your point operations, and first is called your point operation. Second is called your mask operations, and third is called your global operations. So this is the three different types of spatial domain techniques that we will define. So point operation means it will perform in certain single point. Okay, we will have a single point. Whatever the operation is performed, it is performing that point only. It will be not affected by its neighborhood. Okay, what is point operation मतलब जो भी point operation enhancement करेंगे, the effect जो भी होगा वो आपका उस particular point या particular pixel पे होगा, and it will not affect your neighborhood, or vice versa is also true. The neighborhood will not going to change. Okay, whatever the neighborhood we are having, that will not going to change. Whatever the image enhancement algorithm that will perform in the point. Okay, so that means it is only deal with the point. But in case of second type, the mask operation, so we will have a matrix of mass. Okay, matrix of mass. We can say the matrix of 3 cross 3, or from the time we take 6 cross 6. Now this 3 cross 3 or 6 cross this matrix mass will be act as a neighborhood of this point, and this marks will be going to affect when we are going to perform certain image enhancement technique on particular pixel. Okay, we will discuss each and everything on that one. Then global operations, that means every pixel is responsible in your image, every pixel is responsible when you are performing an image enhancement technique. Okay, so let us understand in detail what you mean by, or what we mean by point operation. The first point you have to remember, in point operation, each pixel is modified by the equation that is not depend upon other pixel value. Now this point is very important here. Okay, so what we have said, suppose this is my image representation. Okay, this is my image representation. Now, if these are my point P1, this is my point P1, this is my point P2, this is my point P3, this is my point P4, this is my point P5, this is my point P6, this is my point P7, point P8, and point P. So what the point representation is saying, or point operation is saying, so whenever we modify, now this is my certain image, now we will perform certain transformation or image enhancement technique, then it will give the resultant image. So this will be give the resultant image. Now this particular represent, now if I represent same, now set of pixel is the same. Now I will represent this one as P1 dash, this as P1 dash. Why P1 dash? Now this is modified pixel, okay? Or P2 dash. Now this are modified pixel. P3 dash, P4 dash, P5 dash, P6 dash, P7 dash, P8 dash, and P9 dash. Okay. So what the point operation is saying, so whatever modification, so now suppose I perform, अगर यहाँ पर P1 में certain transformation कर रहे हैं हम लोग, ठीक है? So once I perform certain transformation, what I am getting? I am getting P1 dash. So whatever transformation you are performing or whatever image enhancement algorithm is applied to the P1, it will not depend upon any other pixel value. So whatever the pixel value are neighborhood of this one. So you can see here what are the pixel value? The P2, P5 and P4. Yeah, it is neighborhood of this one. Now this pixel will not going to play any effect. Okay, ये जो पिक्सल है ये जब ट्रांसफॉर्मेशन करेंगे हम लोग पॉइंट ऑपरेशन में, ठीक है, जो भी ट्रांसफॉर्मेशन करेंगे ये पिक्सल का वैल्यू आपका इसको ट्रांसफॉर्मेशन करने में कोई भी रिलेशन नहीं होता. So it will not depend upon any other pixel. So it will only depend upon this pixel value. Okay, so if I say increase this pixel value by the contrast 50, ठीक है, हम लोग बोलेंगे अभी ट्रांसफॉर्मेशन बोले क्या बोले, इस पिक्सल वैल्यू P1 को इंक्रीज करो इसका इंटेंसिटी by 50. Now what the P dash will represent? Now P dash will be represent the intensity level greater than 50. Whatever P1 will have it will have greater than 50. So this is called your point operation. That means whatever transformation or image enhancement algorithm we apply, that will be applied to a particular point. It will not going to depend upon other pixel value which are neighborhood of it. I hope it is clear to all of you this point. Is it clear to all of you this point? What do you mean by point operation? Fine. So if you want to, if you represent, okay, if I want to represent, let me clear this one. Now, if I want to represent general form, now this is the general form representation. Fine. This is the general form representation where your G of EM is nothing but your transform image. Okay, this G of M and you can say if Mn represent your actual coordinate. Okay, now G of Mn is your transformation image, and this is my original image. now f of mm position image. Then this t is your nothing but transformation operator. Which type of operator? Now this is a point operator. Okay, I can say this is my operator or one point operator that is performed on this. So once we perform this operator, so we will get the transformation input. Okay, and it's very simple. So we will take an input image, okay, or input coordinate of pixel. So on this pixel, I will perform certain transformation, okay, or certain transformation or image enhancement algorithm. Okay. Then आप जब भी perform करोगे, so what is the output? The output will be in the form of G of Mn. Now this is your output image. Okay. Now this T represents here your transformation operator. Okay, or which we can say a point operation, and this can be a different type, or this transformation operation can be classified as a linear transformation, non-linear transformations. Okay, this transformation, this T can be classified. We can say two different types. One is your linear. Linear means linear dependencies. Okay, like we convert. If there is a black and white image, suppose I say find the negative of that image, that means convert the all zeros to one and ones to zero. Now there is a linear dependency. And non-linear, suppose for example, if I say transform like algorithmic transformation or your something your if I say exponential transformation, fine. Or there is one more called gamma transformation. So where the we can say where basically where your g of if g of mn is linearly depend upon, if it is linear, once I transform this pixel and is linearly depend upon your input image f of n, then I can say this type of transformation is linear transformation. Fine. For examples like improving the brightness, okay, improve the brightness. Now there is a linear transformation between these two, or improving the contrast, or improving the you can say size of the pixel values. Now these are some linear transformation where the transformation takes place either like a plus f of mn or a into f of mm. Okay, where a is your linear constant value that will be going to modify. But some examples are there for nonlinear transformation where your g of m, okay, non-linear depend upon. Now there is a non-linear dependency on f of xy. For example, if I perform log transformation, or if I perform exponential transformation, or if I perform there is called gamma transformation. Okay. Now when I perform this type of transformation, now the value of g of mn is not linearly dependent upon. Now this is not linearly dependent upon your value of f of mn. And that type of transformation is called non-linear transformation. Fine. Here these two things. It is clear. Now this is a mathematical representation. Okay, this is my mathematical representation, and this mathematical representation, the T is very important. Okay, the T is your point transformation, and it can be your linear transformation and non-linear transformation. So we can define this function now. This mathematical equation in point operation. Okay, in point operation, that means if I'm talking about point-to-point transformation, the T operator, or we can say the T operates on one pixel or exist by one-to-one mapping. You can say there exists a one-to-one mapping between the input image f of mn and the output image f of g of mn. Now, if this is my input image, okay, if this is my input image f of mn, मेरा input image है f of mn. Okay, now same pixel दे दो आप, जैसा हम पहले एग्जांपल में बताए थे p1 p2 like that p3. Now, whatever transformation is performed, so what we will get? So we will get an output image in the form of g of mn. Now, whatever the result we get, now this point, now this values, okay, now these values will basically depend upon one-to-one mapping. That means now p1 transformation, that will give P1 dash. Now P2, same transformation. Okay, a transformation of enhancement algorithm. Okay, now this is point. This will give to the resultant point P2 dash. Okay, now this is P3. Now P3 perform transformation. Now it will give P3 dash. Now what we are actually doing? Actually we are performing point to point transformation or one to one. We can see basically what we're doing. One to one mapping. This will map to this one. This will map to this one. This will map to this one. Right. This will map to this one. This will map to this one, and this will map to this one. So this is these operates on each pixel. Only one pixel, or I can say there exists one to one mapping. Okay. So is this any doubt? So with this, I will close here class. Okay. If you are having any doubt, you can ask me because we have less than 2 minutes, and if we continue next topic, it's not going to cover. Okay. So I will not start the next topic. So if you are having any doubt, so you can go ahead. What we have learned today, we have learned basically why we need image enhancement. What are the need of image enhancement? Basically, image enhancement technique are using image preprocessing. Then we have discussed some of the topics that we were going to cover in this module. Then we have seen what are two broad classified areas where image enhancement technique can be used. That is, first of all, it is in spatial domain, and second of all, it can be used for transformation domain or the frequency domain. But if you are using in frequency domain or transformation domain, then you have to again convert back into the spatial domain. Okay, then we have discussed what you mean by image enhancement in spatial domain, where your pixel value, basically you will perform manipulation in pixel value, and this pixel value is very important. Major role is going to play. And this type of spatial domain can be classified in three different types. One is a point operation, second one is a mask operation, and third one is a global operation. Then we have discussed in detail about the point operation, how we are transforming from point to point transformation, and what the T stands for. T is your transformation function, which can be your linear as well as non-linear. Okay, so any doubt? If you are not having doubt, so any doubt you can ask me. Otherwise, stop here. Fine. So as there is no doubt, I'm stopping here. We will meet in the next class.